back. This is Mr. Hassan's Maths channel. I'm now answering question number 9, part D from the October 2024 Pure Mathematics P3 paper from Edexcel International A-Level. I've split up this question into different parts because each part really is a separate topic. So here we have part D, which is dealing with the topic of integration and finding the area under curves. So it says the region R is shown shaded in figure 5 is bounded by C, the curve, which the equation is given over here. An alternative form of it is given, which we had to find in part C. L, which is the equation of the normal to the curve at the point P, which we were asked to show earlier, is this. So that's the earlier part of the question. And the x-axis. We need to find the area of the shaded region here, bounded by the curve, the line, and the x-axis. So it says use algebraic integration to find the exact area of R, giving your answer in the form P plus Q ln 3, where P and Q are rational constants. Means there's no square roots in them, and they can be expressed as fractions. No problem. It could be fractions or integers. So solutions based entirely on calculator technology are not acceptable. You can't just, put this equation in there in your calculator with the limits and find the answer. You have to show your steps. And we've kind of done the steps in part C. Okay. Oops. In the earlier part of the question, let me just take this and move it down here. So f of x can be expressed in this form. It seemed a bit weird to us when we did it, but it was correct. Now, we can look at the area R, and the part which involves a curve, there's a couple of things we have to find. First, we have to find what the point is where it hits the x-axis. And secondly, we have to find, well, actually, we already have it. This is the point where x equals 2. Okay, so this is where x equals 2, right? Because that's the point P. And this, we have to find the x value of this point, okay, which is one of the places where this curve hits the x-axis, right? Now, we also have this area here. So I call this area 2, and I call this area 1. Area 1, it's pretty straightforward because we have a triangle. This is the vertical height because it's right angled. This is the vertical height, which is 6. And we need to find this length here. Now, this length is not difficult to find. Why? Because it's where this line hits the x-axis. So I call that x2. To find x2, I can find the base. I know the height, I can find the area of 1. So let's start with that. So the area of 1, which is this part over here, we need x2. We need to find what x2 is. x2 is, we have the line 16y plus 5x equals 106. It hits the x-axis when y equals 0. So when y equals 0, you have 16 times 0 plus 5 times, and that will be x2 now, equals 106. So you have x2 equals 106 over 5. So this length here is 106 over 5 minus 2. This length here is going to be 106 over 5 minus 2. Okay, so that's 106 over 5 minus 10 over 5, which is 96 over 5. So this length is 96 over 5. Okay, so the area of a triangle is a half times the base times the height, which is a half times 96 over 5 times the height, which is 6. Okay, that cancels with that, gives you 3. So you have 3 times 90 is 270 plus 18, 288 over 5. That is the area of 1. Okay, so the area of that first part is 288 over 5. Now we've got to find the area of 2. Okay, the area of 2. So the area of 2 we can find by integration. So the area of 2, we have to integrate between the limits of 2 and x1, which we have to find. The expression 3x plus a half, and I'll put this as minus 5 over 2 times 2x plus 1. Or you can say 4x plus 2 if you want to, that's fine. Okay, so I've just rewritten that in a more friendly kind of looking way. Now we need to find the limit x1. x1, okay, x1 is where f of x is equal to 0. Okay, so where this whole equation equals 0, maybe it's easy if we look at this. 6x plus 6x squared plus 4x minus 2 over 2x plus 1 equals 0. So we can solve this equation, multiply by both sides by 2x plus 1. So 6x squared plus 4x minus 2 equals 0. Can divide by 2. 3x squared plus 2x minus 1 equals 0. And now we can use the factorizing that we did earlier in the question, which we thought would not save us any time. Well, it didn't save us time there, but maybe it's going to save that time over here. So we factorize this and we realize that that must be plus 1 here and minus 1 over there. 3x squared plus 3x minus x minus 1. If you're not sure how to do that, you can go back to, I think, part A. And I actually factorized it in part A or B, I think, and showed how to do it in the normal method. Anyway, so here we have x equals 1/3 and x equals minus 1. Okay, so those are two places where it's the x-axis. Of course, x equals minus, hold on. X equals minus 1 is not going to be one of our answers, of course, because it starts from x equals a half. So, of course, that can't be one of our answers. But the answer we're looking for is 1/3. That's going to be, obviously, where it hits the x-axis. All right, so now, so we know this x1 is 1/3. So now we can start to answer the question. This is 1/3. This is the limit of 2. And we have 3x plus a half minus 5 over 4x plus 2. We have to integrate that with respect to x with those limits. And adding that to area 1, don't forget area 1 is over there, will give us a final answer. So some people would forget this. I'm going to highlight that, keep it in my mind. Now, integrating this, when you start integrating, your integral sign turns to a square bracket. You're going to add 1 to the power, so you get 3x squared divided by the new power divided by 2. Plus a constant term will just gain an x, so it's a half x, minus, and this is of the form of the integral f dash of x over f of x. Some constant times f dash of x over f of x. Where if you want to integrate this, we cannot write 5 times 4x plus 2 to the power minus 1. So when you try to integrate 4x plus 2 to the power minus 1, it will give you a problem. You add 1 to the power, it becomes 0. And divide by 0. So here you have to use the reverse of the chain rule. Okay, and when you see that the numerator is of the right order as a differential of the denominator, we can reverse the chain rule. So you differentiate 4x plus 2, you get 4, which is a constant. On the numerator, you have a constant. So what you can, the way I like to write it out is 5 times the ln of the modulus of 4x plus 2. And I've gone into some discussion about what the modulus sign is, or why we write modulus here in a previous video. Then we have to divide by the differential what's inside the function, which is 4. Divide by the differential of 4x plus 2, which is 4. And there we have the integral of that. And we have our limits between 2 and 1/3. Okay, so now we have to put these limits in, and that will give us area 2. So now we got 2 into here, so that's 3 times 2 squared, which is 3 times 2, which is 3 times 4, which is 12, over 2, plus a half times 2, minus 5 times the ln of 4 times 2, which is 8, plus 2, which is 10, over 4, minus, now this is the trickier part, putting 1/3 into here, that's 3 times, that's going to be 1 over 9. 1/3 squared is 1 over 9, over 2, plus 1 over 2 times 1 over 3, that's 1 over 6, I think, minus 5 times the ln of the modulus of 4/3 plus 2 over 4. Remember, this is a minus, so it's going to affect the signs of those. Let's try to simplify this. This gives us 6 plus 1 minus 5 over 4 ln of 10. Okay, once you know this is positive, you don't have to write the modulus sign anymore. Minus This is going to be, that cancels with that, leaving you a third. So it's 1 over 6 minus 1 over 6. And that's going to be minus another 1 over 6. Because it's a minus and a minus. Okay. And then you're going to have plus, because minus and minus gives you plus 5 over 4 times ln of the modulus of, this is 4 over 3 plus 6 over 3, that's 10 over 3. Okay, I don't have to put modulus, as I said, because 10 over 3 is positive. So once you know it's positive, you don't have to put modulus. I'll just put a normal bracket there. Okay, so now let's try to sort this out here. 6 plus 1, which is 7, minus 2, 6, which is minus 1/3. So I've dealt with the numbers. Then I'll write this one first. 5 over 4 ln of 10 over 3 minus 5 over 4 ln of 10. Okay, so to make this a bit simpler, 6 minus a third is 6 2/3. Okay, we can think of this as 21 over 3 minus 1 over 3, which is 20 over 3. That's probably a neater way to write it. And here I'll put plus, I'll put 5 over 4 is a common factor of these two. I have ln of 10 over 3 minus the ln of 10. Okay, now we can combine these together. We know that the ln of A minus the ln of B is equal to the ln of A over B. To have the same base, which is log to the base E. So I can do the same thing here. And let's see if I've got enough space. So I have 20 over 3 plus 5 over 4 times the ln of 10 over 3 divided by 10, which is times 1 over 10. So these cancel out. So we're left with 20 over 3 plus 5 over 4 times the ln of 1/3. Now, they wanted us to have ln of 3. That's no problem, because we know ln of 1/3 is the same as minus ln of 3. Okay, so I can write this as 20 over 3 minus 5 over 4 ln 3. There's the answer in the form. Oh, what did I forget? That's not the final answer. Okay, that's just area 2. We've run out of space here a little bit. Okay, I'm going to cheat a little bit here and make some more space. Can't really do that here. Anyway, we'll have this space over here. Okay, so this is the area 2. So the total area is going to be area 1 plus area 2, which is equal to, what's area 1? It's 288 over 5. So you have 288 over 5 plus 20 over 3 minus 5 over 4 ln 3. So these two have to be added together. I'll just use a calculator for that. So you have 288 over 5. Come on, calculator, where are you? There it is. So you have 288 over 5 plus 20 over 3. That gives you 964 over 15. So you have 964 over 15 minus 5 over 4 ln 3. I should have really gone to the next page, but there's the final answer for this question. Okay, so that's a bit of a lengthy question actually, because even that was just part D, took us a bit of time. So it's quite a long question. So I hope that people got time to finish it in the exam. But yeah, we have to think quickly and understand what we're doing without having to stop too much. But there's the answer. You can check your answers correct by putting these separately into your calculator. So you can check this answer is correct and check that answer is correct as well by using the integration button, and you can see if it's right. It won't give you the same exact form, but you can check it right that way. So for example, I could take this. I could take the original equation here, and I can put it in between the limits that we found, just to illustrate how we can use the calculator to check the answers. It's useful. You can't use your calculator to give the answer. If I just wrote the answer down without showing any steps, in fact, you can't even write the answer down in this form anyway. It will just give you the decimal equivalent to it. So it's a checking tool more than anything. So we have the integral button over here. Okay, and we have an algebraic fraction, so we don't have to put the bracket because this is one term. So I'll put it in its original form. So 6x, so here, this is the x and this is squared, 6x squared. Plus 4x, 4, so I use this x over here, minus 2, that's over 2x plus 1. And then we can put the limit in, and the limits were 1/3, 1/3 and 2. So 1 over 3 and 2. Now that will give us an answer. It'll take sometimes a little bit to work out straight away. So 5.2934. So I'll save this answer. Okay. Okay, so I'll save this answer as A. All right, so that will give me this decimal. So now we're going to find area 2, which is 20 over 3. 20 over 3. Minus 5 over 4. Ln 3. All right, so that gives us exactly the same answer, I think. Let's do recall 5.293. So recall A, 5.293, exactly the same. Okay. Yeah. So we can see that we've got the right answer. In an exam, you don't have a mark scheme, so you can check to see that you got the right answer. And if you have time, you can go back and correct something if you made a silly mistake. It's very easy to make silly mistakes in these type of questions. All right, so there's a final answer. That was just the answer for part A2. This is the final answer, okay, which is adding the area of the triangle to it. So that concludes this question, and that concludes, I think, this paper. Yes, it does. All right, so this is October 2024, completed of P3 International A-Level. And this is part D of question number 9. Parts A and B and part C are separate videos, which you'll find in the playlist. And the other questions from this paper in the top right of the screen at the end of this video. Other questions from the topic of integration, you'll find in the playlist over here. You can subscribe to my channel by clicking on this link, and the link on the top here will show you how to use my channel to find things efficiently that you're looking for. Thank you for watching, and see you soon.